We'll now give the floor to Dr. Benedetti. Please stay within your time limits. We're a bit late. You work at the Department of Biomolecular Sciences at the section of Clinical Biochemistry of the University of Urbino, Carlo Bo, and the presentation is the state-of-the-art of research on cell food, especially with respect to the antioxidative effect, cells, biomolecules, and the anti-proliferative activity against cultured tumor cells. Good morning. This state-of-the-art in research at the University of Urbino takes us back to last year. At this very same Congress, I presented the preliminary results of our research on cell food. Results about assessing the antioxidative power of cell food. If you were not there last year and didn't hear my presentation, I'll show our experimental design again. We selected for targets of oxidation two molecules, GSH, which is glutathione, a DNA molecule, and two circulating cells, red blood cells and lymphocytes. Each oxidative target was incubated with an oxidating species, and we tested three different types: hydrogen peroxide, peroxyl radicals, and hypochlorous acid, three reactive oxygen species which are normally produced by normal cell metabolism. Our targets were incubated with the oxidative agents in absence and in presence of increasing doses of cell food. And then we checked the antioxidative power of the substance. Results were quite satisfactory. As regards the glutathione, GSH, with no cell food, there's maximum oxidation, considerable reduction in GSH concentration in our reaction mix. But with increasing doses of cell food in our mix, we have a dose-dependent increase in GSH concentration. So cell food protects GSH from oxidation and represents an antioxidative protection. Same for the DNA molecule. No cell food, maximum DNA oxidation, and loss of DNA structural integrity. When oxidation occurs with increasing doses of cell food, we have a dose-dependent recovery of DNA structural integrity. So you can see the nucleic acid molecule is preserved with its genetic information. As regards the circulating cells, the red blood cells, oxidation without cell food caused important cell oxidation, hemolysis. The red blood cell membrane broke down with cell hemolysis. With increasing doses of cell food, we can see a dose-dependent reduction of cell hemolysis, so protection of the red blood cell against oxidation. Results on lymphocytes, no cell food, maximum free radical formation. With increasing doses of cell food, we have a dose-dependent reduction of intracellular free radicals with reduction of intracellular oxidative stress. So as a whole, results have major clinical implications. Cell food and DNA protection. Protection is very important for mitochondrial DNA, which is particularly exposed to free radical action during cell breathing. The mitochondrial DNA oxidative stress is involved in many degenerative processes and in the aging process, so cell-food supplementation is essential to prevent a number of disorders where mitochondrial dysfunction plays an important pathogenetic role. This is an example of a paper published in 2007 where treatment with Cellfood led to improvement in symptoms in patients with fibromyalgia versus placebo. Cellfood can be extremely useful in the clinical treatment of patients with mitochondrial damage. Similarly, again about the importance of cell-food protection against red blood cell oxidative damage, especially in case of strenuous and prolonged physical exercise in athletes. We have increased oxygen consumption and overproduction of free radicals by red blood cells and white blood cell activation. We have considerable membrane lipid oxidation, increased permeability, hemolysis, and possible onset of anemia. In this situation, cell-food protection for red blood cells could be very important in preventing anemia in athletes with a number of benefits in terms of performance and better training and recovery results. This is a study on Cellfood in professional cyclists presented in Oslo in 2009 at a conference on sport medicine. Cellfood supplementation during training promotes performance, improves performance. Results were published on Italian international journals. This is the paper published in April on Pharmacia News, an Italian journal, and the results were then published on Food and Chemical Toxicology, an international journal, in order to have a more international circulation of results and cell-food function. We're now studying the anti-proliferative capacity of cell-food, so protection against tumor growth. Research has been carried out in vitro, and tumor cell lines have been cultured. The first experiment is about a leukemic cell line, T lymphocytes and Uricate cells, incubated with increasing doses of Cellfood. After 24 hours of incubation, we checked cell proliferation. Results, again, have been really encouraging because with no Cellfood, that's a control, we have maximum cell growth, so 100% tumor growth with increasing doses of Cellfood in the system. We can see a reduction, which is dose-dependent, in cell proliferation up to 45% inhibition. Results are quite encouraging. And we're now continuing research to check the anti-proliferation effect in other tumor lines. In cooperation with the Regina Elena Institute, they provided the cell lines for our study. We considered 8 different lines: melanoma, mesothelioma, carcinoma, colon, bladder, lung, and breast. The different cell lines were cultured without Cellfood at a fixed concentration and check results after 24, 48 and 70 hours of incubation. Results were very good on the 2 melanoma cell lines. Cellfood obtained with Cellfood versus control with maximum growth is 36% in the first line and 50% in the second melanoma line, with maximum growth inhibition after 48 hours of incubation. Mesothelioma inhibition of growth was observed after 24 hours. Inhibition ranging between 20 to 35%. Lung and bladder carcinoma, maximum inhibition was obtained after 48 hours, the range being from 16 to 26%. Colon and breast cancer, maximum inhibition was between 17 and 21%. So Cellfood is active against all tested tumor lines with different degrees of sensitivity. Certain lines, in fact, were more sensitive than others. Cellfood was effective at 24 hours in some cases, at 48 in others. But of course, we need to further investigate Cellfood mechanisms of action on these cell lines. And as stated by Professor Canestrati, the most credible hypothesis is that there is a displacement or a movement of metabolism from mitochondria to cytoplasm, with the suppression of apoptosis and resistance to cell death. So increased resistance to cell death. Tumor cells resist apoptosis. Without Cellfood, with Cellfood we have a metabolic shift. The mitochondrial pathways reactivated. Cells are more susceptible to apoptosis and with increased cell proliferation, with reduction in cell proliferation. This has been recently confirmed by this paper, who showed that supplementation with Cellfood of cultured cells leads to increased oxygen consumption, increased mitochondrial activity and ATP production. Conclusions are that there is a Cellfood-induced metabolic shift. There are two research fronts, if you like: the antioxidative action of Cellfood, so against the most common physiological oxidants. Also, Cellfood is indicated in all stress-related physiopathological conditions, from oxidative stress, cell aging, cardiovascular risk, and neurodegeneration. It is particularly indicated in case of intense physical activity, with increased oxygen consumption and overproduction of free radicals. The research has shown that Cellfood can lead to a reduction in tumor growth. So based on our results, we can conclude that Cellfood can be considered as chemopreventive and a support in tumor treatment. We need to further investigate the mechanisms underlying this overproliferation effect in order to be able to promote additional clinical applications. Thank you very much for your attention. I would I'd like to thank Dr. Simona Catalani, who is here with us today, who has helped me a lot during our experimental work on red blood cells and lymphocytes. Thank you very much.
Grazie dottoressa, è veramente interessante, per non dire stupefacente, notare come Cellfood.
It's interesting to note how Cellfood is not just valid in the light of research as an oxidative protector, but these studies have also highlighted that Cellfood also has an anti-proliferative effect with a reduction in cell growth. So certain tumor lines, if I've understood correctly, were more sensitive than others to Cellfood, with up to 50% growth inhibition. So these are significant findings.